Welcome to part 4 of section 1 of the limited online lectures on beef cattle breeding. Just a quick reminder, in part 3 and 2 we looked at the different types of mode of inheritance of traits, different traits. The simple inheritance where one or only a few genes are involved, also called Mendelian inheritance, and we also talked about the possibility of dominance and recessive genes, where the same gene in different forms, the one form can be dominant over the other. In terms of those type of traits, we saw that there's very distinct classes like coat color, for example, where an animal can either be black or red, or horned or polled, or some recessive genes that keeps hidden in the populations, for example, like double muscling or the myostatin gene or other congenital defects. More importantly, from a breeding perspective or a production perspective in beef cattle, would be those traits that are influenced by a multitude of genes, each having a very small contribution, so-called quantitative traits or gene actions or additive gene actions, where you add up the effect of each of these genes. They have special properties, those traits or traits. For example, you usually have a normal distribution or a distribution in the observations, with most of the animals performing close to the mean or the average of the group, and less on the extremes. It's also small increments or a continuous difference in performance or recording of those traits. The other very important property of these traits would be that they are also influenced by the environment. So the expression of that trait, it's not just the genetic action or the genes that would make a difference in the expression of the trait, but also the environmental influence. If an animal, for example, is born in a good year with luscious grass and so forth, it will be heavier compared to a bad year. So there's an environmental influence. The other property then is what is the ratio of if we work out the variance in measurement or weight, for example, how much of that is caused by genetic differences amongst the animals in relation to the environmental influence, and that we call a heritability. So we can calculate or estimate the heritability for such traits. We also talked about the other property of these traits, that they are genetically linked or correlated because of these genes on different parts of the chromosome can be very close on the same chromosome, or on different chromosomes that are inherited or transferred to the next generation. And that means that if you select for one of these traits, it will definitely have an influence on another trait if they genetically correlated. So in part 4 then today, we would like to carry on and talk about the principles of breeding values. The first principles, I call it the first principle of blood breeding values. Now, a breeding value can simply be defined as the value of an animal as a parent. And remember, an animal will have a breeding value for a specific trait or property, and that value means how do we compare two animals in terms of their value for that trait, and we can, and in the end, it will pan out in terms of the progeny differences in progeny performance stemming from these two. Okay, so we can kick off by looking at these two pictures of two cows. The one on the left being better conditioned than the one on the right hand side, and now one can ask the question, which one of these cows are the most desirable of in terms of your production system. And you can have all sorts of arguments, but I think it boils down to the fact that you cannot compare these two cows unless you have more information available to enable you to compare them. So other information available is what's the age of the cows. Did she just sort of wean the calf or not? Is it a good or a bad year? What is the felt like? What is the feeding like of these two cows? How were they raised? So there's a lot of other questions that need to be answered first before you can just make an assumption as to which cow is the best. So in all, or in short, we can say that the environment affects the expression of the gene. So any of these cows can be genetically superior to the other one, but the expression of those genes can be elevated or can be suppressed by the environmental influences on the expression of those genes. So we can then basically say that the phenotype or the measurement or the physical appearance of an animal equals the genotype, the genetic makeup or the genetic code in the animal, plus the environmental influence. So in both cases, let's take the top example, our thinner cow, she might be superior in genetics in terms of body condition, but due to the fact that she was subjected to adverse conditions, she ends up looking like that. And that could be just the reverse for the other cow. So we need to say that you cannot compare animals across environments if you do not have more information about certain properties or conditions. Okay, to just sort of get going in terms of breeding value predictions, we also talk about EBVs, estimated breeding values. So BLUP is the methodology being used to predict the genetic merit of an animal or the breeding value of an animal. So you predict that or you estimate the breeding value of an animal. And as I said, it's the value of an animal as a parent for the next generation. So principally, what's needed from the farmer or the breeder would be the pedigree information, and we will talk about the value of the pedigree information and the performance information of these animals. Performance is defined very broadly, and I would like to stress that. It's oftentimes said that performance recording is all about growth. It's not just about growth, it's also reproductive performance. It's traits like longevity, it's traits like maintenance requirements, it's traits like feed efficiency. So it's a very broad definition of performance. So that's needed, the performance recording. Recording, it means that no guessing, recording, and the pedigree information. And that goes into a genetic evaluation system, and the outcome therefore would be the breeding values or the EBVs. For those specific traits for each of those animals. Let's just then look at pedigree information, and I think this is very important that one would say, what does a relationship between two animals mean? It means that they share common parts of the chromosomes or the genes. So if we have bull X here, we know that there's only one place that his genetic makeup can come from, and that's from his sire and his dam. So he shares 50% of the genotypes or the genetic part of each of these parents. And on average, he would share 25% of each of his grandparents. So I say on average because once we started using genomic information, we would say in certain cases, because of the randomization of these genes flowing down from top to bottom in the pedigree tree, sometimes through the randomization, it could mean that he could be more related to some of his grandparents than to others. But from his parents, always 50-50. And he will always share 50% of his genotypes or his genes with each and every one of his progeny. So that's also a given. It can't be different than 50%. In terms of his grand progeny, on average, listen, on average he might share, or he will share 25% of each of his grand progeny. So that's on an average basis. He will, on average, also share 25% of his half sips. So that means, let's say, for example, one bull was used on 30 cows, and this bull is one of the 30 progeny emanating from those matings. On average, he would then share 25% of his genetic makeup, or his genotype with each of these half sips. And when it's a full sip, like where you have litters in pigs or twins or trips in sheep, such an animal will share on average share 50% of his full sips. So that's the principles. So if we talk about the genetic relationship, or what are the relationship amongst these animals, it means that they share parts of the genotype of those animals they are related to. So if we say that pedigree information is so important in the prediction of breeding values, it means that we take that in consideration. So if for example an animal shares 50% or 25% of its genotype with some relative, it means if we record the performance of an animal in a specific situation, and that relative is being recorded in a different situation or a different environment, it's as if you then also record a quarter, if it's 25% of the animal's performance on a different farm or in a different season, or whatever the case might be. So what happens then if multiple sizes is used in a mating situation, and the parentage has never been established of those ones, or there's an unknown parent, or even a wrong parent for that matter, then it means that information is lost, and only half the information, let's say the information from the dam, can be used in the prediction of the breeding value. Now this is very important when the prediction is done prior to the animal having had an own measurement. It means that we have to rely on the fact that it shares genes from the parents, and that sort of elevates or decreases the genetic level of the animal based on the parent information. So if one of the parents' information is not available, it basically means that it reduces the accuracy of the prediction, that especially the early prediction. So it's crucial that complete and accurate pedigree information needs to be used in the prediction of genetic merit or breeding value predictions. Okay, so obviously if we talk about the breeding value, we talk about the value of an animal as a parent. So how much better or worse or higher or lower will the progeny of a specific animal perform compared to the progeny of other parents. So obviously if you have progeny performance of an animal, it will increase the accuracy of your prediction, because it basically tells you what the difference in performance of the progeny is compared to the progeny of other animals. And we call it a breeding value because how does the animal breed? Does it breed better or worse than other animals, other parents? And obviously it can be a one-on-one between two bulls, but more importantly, amongst all the bulls may be available in a breed for breeding purposes. This brings us to a very, very important concept, the concept of a contemporary group. If we look at the two calves here on these two pictures, the Sponsmara calf on the left and the Nguni calf on the right, would one be able to say that you can compare the weights of these two calves and say the one's better than the other? Obviously not, because for different reasons. The one would be that maybe the calf on the left is much younger than the one on the right hand side. Or one can also say this was a bad year, calves are lighter generally, the cows produce less milk, their mothering ability is negatively affected by that. The other problem could be that there's a difference in the age of the two dams. So the one dam might be younger than the other one, and the maternal ability is negatively influenced by that, and so forth and so forth. So there are different reasons why you cannot compare these two calves in terms of weaning weight. In this instance, for example, it's a better comparison because these animals form a contemporary group. Those are heifers born and raised on the same farm. There are critical other information. They are of the same breed, so the genetic merit is being predicted in the same breed, and they are comparable. It's like somebody competing in the same race, 100-meter race, where the conditions are the same, it's the same track, it's the same time of day, it's the same at the same altitude, and it's comparable. Whereas it could not be comparable with maybe another race at a different venue, at a different time of year, and with other weather conditions. So basically, a contemporary group levels the playing field and it enables one to compare animals within the same environment, within the same treatment, and within the same type of conditions that they had to perform in. So the principle is that the environment needs to be the same for all animals, and that the differences that are expressed, or the variation that one measures, given the differences in the heritability, would enable you to compare animals genetically. So it should be animals exposed to the same environment. So as a principle, it will be animals born in the same herd year and season, on the same nutritional plane. So if some animals were treated differently to the one group, you cannot compare them. They need to be compared in their own group. They need to be treated exactly the same. And then one can also make some corrections for differences in the sex of the animal, the age of the animal, the age of the dam, and maybe the parity of the dam can also be tested to have an effect on, let's say, weaning weight and so forth. And that forms the basis of breeding value estimation. Oftentimes the question is asked, how do you take out the environment in blood breeding values or EBVs? This is the way you take out the environment. You always record animals within the same contemporary group, within the same environment. So the principle of BLUB is that your recording of the performance would be in the same environment, in the same contemporary group. A level playing field is being used. Good, let's then look at how BLUB works in terms of using a contemporary group comparison. Here you have 4 calves weighed at weaning, let's say it's 7 months old. The heaviest calf was 210 kilos and the lightest calf 190. The average of the group was 200 kilograms. Now, the actual weight is not considered in the prediction of breeding values. The actual weight is not considered in the prediction of breeding values. What's really considered is a deviation from the average. So in the blood predictions, these deviations are used and not the actual weight. So in terms of the heaviest calf in this instance, he was 10 kilograms heavier than the average, and the lightest calf was 10 kilograms lighter than the average. So that those values are being used and not the actual weight. Okay, so by doing that, the environmental effect is basically taken out or considered. So here's our example of we just looked at now. Average of 200 kilos on a different farm or a different year. You will see here are also the 4 calves are also being weighed for weaning. The average in this case is only 160 kilos as opposed to our first group being 200 kilos. And you can now say that in the lighter group, we have environment plus genetics in terms of the weights. That's why we have 160 kilos here. In the heavier group, we had an average of 200 kilos, but the lightest calf in this group weighed 190 kilos, but he was 10 kilos lighter than the average. 200 minus 190, 10 kilograms lighter, whereas this 170 kilogram calf in the different group or in a different farm, where the average was only 160, was 10 kilograms heavier than his peers. So this is the important part. You're comparing the plus 10 with a minus 10 and not the 160 with a 200 kilogram. So in this instance, the 170 kilogram calf was actually genetically superior to the 190 kilogram calf. So that's the way that blood actually separates the environment from the genetic part. We work with a plus 10 kilos and not with 170 kilos in this instance. We work with a minus 10 kilograms and not with 190 kilograms actual weight in that instance. So in principle, this is a very simple way of separating the environment from the genetic part. Obviously, not the whole 10 kilogram superiority will be transferred because there's still an environmental influence, and we have said that how do we deal with that? We also include the heritability of the trait in this. If for example, this is only 30% heritable, the plus 10 kilograms multiplied by 0.3 means that it's only a 3 kilogram difference in terms of genetic difference. Okay, so this also have an influence on how you deal with the contemporary group. For example, if you have your first example of the 4 calves with an average of 200 kilograms, and you have these deviations from the average, and for some reason you add a sick calf to the equation. So you have a sick calf, he only weighs 150 kilograms. All of a sudden you will see that the deviation, the mean is being pushed down due to the average now over the 5 calves, and that means that your top calf in this case was 10 kilograms heavier than the mean. Now all of a sudden he's 20 kilograms heavier than the mean. So that's a false, basically give you a false impression or a false breeding value prediction for the other 4 calves. So your below average calf all of a sudden is now an average calf. So this is just a caution if you put these contemporary groups together, that you need to be very cautious by the fact that you have to compare apples with apples, and don't elevate the genetic merit of a calf or an animal by trying to compare it with an animal that was subjected to an external environmental influence that could influence the performance of that animal. So I've shown you that the 10 kilograms all of a sudden becomes 20 kilos, and that calf's elevated to a level that he did not deserve. So the effect of this is that in your first genetic breeding value prediction, you overestimate those predictions for the top 3 calves, or top 4 calves in this case, and that has a very poor stability influence on breeding value predictions. Maybe I should just at this stage pause a little bit to say that why would somebody predict the genetic merit of an animal? So that you can make a selection decision. So any farmer would say, I do this on my own behalf or for my own good, so that I can pick the right animals in my breeding program. And doing this type of or this type of practice will then actually thwart your own selection decisions in the future. Okay, so this also means that if we talk about a contemporary group and you only have two animals with weights in a contemporary group, one will always be above average and the other one below average. So this is also, I would say, not a good practice. So one will have to look at the size. You always have to, in the back of your head, keep in mind that the size of the contemporary group also has a marked influence on the stability and the accuracy of the breeding value prediction. And obviously, if there's only one animal, it will always be on average. What we at Statboek will do is we will not include animals in or the weights of animals or the measurement of animals unless there are 3 or more animals in a contemporary group. Okay, this is just a quick exercise. And I think this is just a recap of what I've said so far. Which calf is genetically the heaviest for winning weight? Is it the calf that weighed 170 in group 1 or the one that weighed 190 in group 2? Now it's obvious that this calf was the heaviest calf in this group and that calf was the lightest calf in that group. So although this calf weighed 190 kilos, it was 10 kilos lighter than the average of the group. And that calf was 10 kilograms heavier than the average of his group or the group that was subjected to the same environment. So this is obviously on the left hand side in group 1 is the more superior calf of the two. This is just an expression of what I've just said. Okay, so just some broad guidelines for drafting of contemporary groups, so animals are automatically placed in a herd year season group. So if you have a calving season, all those animals will immediately have their own group and obviously within herd. The sex of the animal is being taken care of. Male and females cannot be compared, obviously. The age of the animal is being corrected, so it's included in the so-called blood models. The age of the dam, very important. Obviously, you would know that young females, they don't look after their calves as well as your senior cows, and then the very old cows, the same story. The parity has also got an influence irrespective of the age of the dam, and obviously the time within season. Your early season calves could be different genetically could be definitely be influenced by the environment than those born later on in the season. So this is all being taken care of in terms of the blood models. The farmer actually knows a little bit more. So if you are aware of any other treatment differences amongst animals, then that needs to also be recorded so that is taken care of in terms of the comparison. So these are the things that the farmer knows and can then also add as treatment differences. The one is obviously supplementary feed. So especially where these calves were treated differently in terms of supplementary feed, then it needs to be recorded. Different camps or farms, if the camps are very similar, then there's no need to treat those animals or see that as a difference in treatment. But usually where there's a farm difference, where farmer farms on more than one farm, then that needs to be part of the recording. Illnesses or injuries, I've mentioned that in the example. When new animals are brought in, that needs usually there's an adaptation period where the animal needs to adapt to the new circumstances. If there are special treatments for shows or sales or whatever the case might be, and those animals get extra supplementary feed, that needs to be recorded as well as the possibility where there are differences in rearing status or anything else that might affect the performance or the recording or the value of the trait that's under consideration. Just some other guidelines. Try to make the groups as large as possible. if the groups are very small, then it's difficult to really compare animals in a small group. And if there's one animal mistakenly put into a group, it will affect not just that animal's genetic merit or the prediction, but it will also affect the other animals. 1 in 3 will have a bigger influence than 1 in 20, for example. It's also important to have calving seasons so that you can lump those calves together into a smaller group, and it's a more comparable group. You're leveling the playing field. The season is the same for everyone. And like I said, mistakes are more critical in smaller groups. And remember that family information will rectify mistakes. So if you have a calf coming out of a very good line, but its own weight it's not reflective of the line that it's or his family members, then blood will draw me a little bit closer to what you expect from that the family members. Unknown sires, I've mentioned the effect of unknown sires or multiple sires if the parentage is not sorted out, can also be detrimental to the accuracy and the stability of breeding value predictions. A very important part in breeding value predictions is so-called genetic linkage. This is just an example of 4 bulls, sires, herd sires, named Tom, Raka, Sammy and Jackpot, and each of them were used in different herds. So in the first instance, there were progeny born from Raka, and the average weight of this progeny at weaning was 220 kilos, and those of Tom were 210 kilos. So obviously, in terms of this herd, Raka was superior to Tom. His progeny weighed 10 kilograms heavier than the progeny of Tom. In a second herd, there were 2 bulls used called Jackpot and Raka, and the progeny of these bulls were weighed, and they were equal. So in terms of this herd, they were on the same genetic level. Then in the third instance, in the third herd, there were progeny of Sammy. There's Sammy, on average 190 kilos, and Raka 180. Sorry, you can't see it so well, but 180 kilos. So in this instance, Sammy was genetically superior to Raka by 10 kilograms in terms of the progeny performance. So the question would be, what if you have to rank these bulls in terms of the genetic merit, which bull it would be superior for winning weight? If one looks at it, when Sammy competed against Raka, he was 10 kilograms. His progeny were 10 kilograms heavier. When Raka competed against Jackpot, he was equal to Jackpot. And when Raka was compared to Tom, Raka was superior to Tom. So in terms of ranking these bulls, the most superior bull is actually Sammy. Although Sammy's progeny weighed less than the progeny of Raka in this instance, or Raka in that instance, when he was compared to Raka, he outdone Raka by 10 kilograms. So you can see that's basically the way blood breeding values also deals with comparing animals over different environments. First, the performance within contemporary groups, but then you have these link sires or genes that's being expressed over different environments, and that enables one to make a comparison over different environments in terms of breeding values. So, okay, that has now been answered basically. This is just another example, and I think this is an exercise. I'm not going to go through it, but you will see that you have different bulls: Jack, Nelson, Victor, Roy, Apollo and Jerry. and maybe you can go through these questions and see whether you are able to actually rank these animals in terms of their genetic superiority for winning weight in this case, and also are all these herds well linked or not in terms of your breeding value prediction. Okay, so just some other contemporary group guidelines. The one is try to always have the progeny of more than one bull in each of these groups. We have said if you have a breeding season, you can have each bull with his cows in a separate camp, but after the breeding season, mix the cows, or take a few cows from each of these groups and mix them, send them to another camp, so that you basically mix them up, and you have, when you do the weighings at weaning, that you have progeny of different bulls in the same group. And if you have smaller herds, try and artificially inseminate some of the cows, so that you just bring in a second bull and compare the progeny, so that you can compare the progeny of different bulls within contemporary groups. So the ideal would be a contemporary group of at least 5 animals that would be the progeny of at least 2 sires. So try and increase the size of your contemporary groups to be beyond 5 with a progeny of more than 1 sire. The next item I would like to enlighten is the measuring or selective measurements. If you have these 6 calves and you have weights of the 6 calves, and these are the deviations from the average. Remember, blood works with the deviation from the average, and you will see that your heaviest calf was 3 kilograms heavier than the group average, and your lightest calf was 3 kilograms lighter than the group average. So if there's selective measurements, let's say for example this farmer decides he's only going to weigh the 2 heaviest calves. Can you see what happens is that now all of a sudden your best performing calf now he used to be 3 kilograms heavier than the average. Now he's only 1 kilogram heavier than this new average, and the second calf, who was actually a superior calf, now becomes an inferior calf, because he has to compete against a new average in that case. Okay, if you just don't weigh the poorest calf, what will happen? You take him out. Can you see that there's also a shift in the mean? This is just a rule of thumb to say, look, if you really end up splitting your contemporary groups or making them too small, you end up with a huge number of groups. So try and reduce the number of contemporary groups, so that you end up with more animals per group. That then brings us at the end of part 4, maybe a longer lecture than the others, of our first section of the limited online lectures in beef cattle breeding. We will continue, or you can continue at your leisure, with part 5 after this. Good luck with the rest of the lectures.